Okay, right now it's 10 o'clock. I think we can start as soon as possible and leave some time for Daniele to go back to the bed, right? Okay. Okay, good morning, everyone. So welcome to CCAMP session. So I think this time it's a little bit different from the previous ones. I'm alone here sitting by the, chair's desk. But, because, Daniele cannot make the trip, but he's still with us. He's online. So we can have the meeting as usual. So this is a load well information. I think everyone should be familiar with this kind of policy stuff. But I would like to remind one sentence. It says that if you are aware that IETF contributions is relevant for, it's covered by any patent, you must disclose the IPR or the fact. So if you are new to the IETF, and I think you should take a look at this information documents, and you can get more information from the link. So this time we have only one session right now. So actually you can also download the slides from the link below. And looking at the agenda, so this time we still have very busy agenda. So please spend your time efficiently, and we could leave more time for open discussions. So please follow the agenda. So as usual, we have the audio and video recording. So please speak in front of the mic, and also please state your name before speaking. So for the meeting echo, and Daniele and I, we both are in the meeting echo, and we will monitor if there are some comments from the remote participants. And for the minute takers, I would like to ask how many to take the minutes, and also it will be much appreciated if anyone can input something that you hear, through the Etherpad. That will be great. Thank you. So for the IPR, this is the reminder on IPR. So I think IPR is really very important and sensitive, stuff. So actually, before a working group document moving to next step, and usually the chairs will send out IPR polling. And for example, before individual draft, becomes a working group document, or a working group document goes to last call, the chairs will send out IPR polling on the list. And it requires all the authors and contributors of the draft to respond to the IPR polling as soon as possible. Otherwise, it will delay your draft to move forward. So, and also, as usual, we always, encourage people, CCAMP people, to, to use the list as much as possible. So on the list, we could discuss any technical stuff. For example, we could discuss some open issues on some drafts, and also we can introduce some new drafts and some potential new working group topics on CCAMP. Another important mandate is that, actually working group consensus is determined on the list rather than, on the face-to-face meeting. So even though here on the face-to-face meeting, we get some consensus here, we still need to bring it on the list because, some people, maybe they cannot make the trip to here. So, but they can say something on the list. So it's better to, we must, bring the consensus determination on the list. So for this, I think for the working group status, I think my co-chair Daniele, he would introduce the left part of the presentation. Daniele, it's your time.
Yep, let's try.
Yeah, you can tell me next page, and then I can change the page for you.
Okay.
Yeah.
Next, please. Okay, so since last meeting, we have two new RFCs, the Ethernet traffic parameters with availability information, and the young model for alarm management. Thanks a lot to the authors for the huge work that was needed to bring these two documents to the RFC status. We have nothing in the editor queue at the moment, but we have a lot of drafts actually, which are mature enough to be progressed. We had a discussion on which ones to move on to progress now. The types documents are probably the next in queue, and then we will go on with the topology models and the tunnel models. Next, please. Status. There are 3 expired drafts. We would like to understand what's the plan of the authors here. Actually, we're not seeing much discussion and on the mailing list about them. So I don't know if there are authors in the room that would like to spend some words on the status of these drafts. Thanks for the video. Now I can see if someone is going to the mic for an update.
Hello, Hamian speaking. Regarding the first one, FlexiGrid Media Channel Young, this work is related highly with layer 0 types, WSON tunnels, and also the TE tunnels, generic from the TIS working group. So this one has not been touched so far according to the frequent change of those kind of draft, and I think it would be updated to the next iteration once those models are stable. So, yeah.
Okay.
Okay, let's move on. Drafts on the agenda. So we are going to have quite a packed agenda today. A lot of working group documents will be discussed. It's nice to see the layer 0, layer 1 types, so that we can have the feeling whether these documents are ready or not. I have actually requested for the young data review for both of them, and I've seen the documents comments coming from Tom on them, so we can consider them as last call comments, and we are ready to start with the PR polling and then the working group last call. Next, please. So, working group drafts not in agenda. We received I don't remember why some of them are in a list, some others are on the other. No changes since the last meeting on these two, but we can discuss them offline. That's not a problem. Next, please. Next, Fatay, please.
I already turn to the next page. Which one?
Okay, it seems it's frozen. Well, let's keep the document status and let's move on.
Yeah. Can you see the page?
Yeah. Let's move to the next one. Let's keep the document status. Okay. Transport NBI. ready for working group last call. WSON impairment verification info, no technical changes. Probably it's another draft that is ready for last call. So a lot of work to prepare these documents for last call in the upcoming weeks or so. WSON tunnel model. This was updated accordingly to the layer 0 types. So layer 0 types is a pre-requirement, but it seems that this dependency has now been cleared. We just need some further alignment to the base model, which is obviously the one that it augments the IETF from TIS, which seems to be now in a pretty good shape, but I don't think it's in the editor queue yet. Next, please. Okay, we have the classical periodical liaison coming from study group 15. We are working on a reply. Scott Mansfield is working on this. There is also another liaison coming from ETSI, or better, a communication coming from ETSI. It was presented on Tuesday in TIS. This is, I would say, a little bit more relevant to TIS than CCAMP, but it was sent to both. It's basically talking about a new work that ETSI is doing on the WIM, the One Infrastructure Manager. They are looking at ACTN as a possible reference for their work. That's why TIS is probably the main receiver for this draft, but all technology-specific extensions to ACTN are done in CCAMP. So that's why CCAMP is relevant as well. So this was sent, if I correctly remember, something like 3-4 weeks ago. So if you have the chance to look at it, that would be helpful. Next, please. Thank you. I can enjoy, have a good session.
Yeah, let's move to the next, presentation.
That's me, right?
Yeah.
Get to presentation mode. Yeah.
Yes.
All right.
Yeah.
Good morning. Yeah, I think I need to. Good morning, everyone. My name is Dieter Beller. I'm one of the editors and co-authors of the draft that is providing augmentations for the TE topology in order to support optical impairments for our WDM networks. I'm going to provide an update what we did since the last meeting, and come on. Okay, doesn't work properly. Not the previous one. Previous page, please. Yeah, this one. Yeah, the major activities since IETF 105, we are actually meeting every week. So we have an official CCAMP call, WebEx meeting every Thursday from 4 to 5 p.m. European time, where we try to progress the draft. And the major topics that we addressed since the Montreal meeting were we actually discussed the ROADM model. So we had some discussions about ROADM architectures, and I have a couple of slides presenting those. The outcome of the discussion was that we added a section in the draft that describes these architectures, and we also discussed how to model the optical impairments imposed by ROADMs. So we agreed to start with a simple approach, addressing homogeneous ROADM architectures first, and then move to more complex architectures in the future might be. And during that discussion, we actually identified 3 paths that have optical impairments associated with them. So there is an express path or pass-through path, an add path, and a drop path that will be used in order to describe the optical impairments imposed by the ROADM. We also had some discussions regarding 3R regenerators. Those discussions have just started. We were focusing on the ROADM modeling first, and I have a couple of slides that describe the 2 options for implementing a 3R regenerator. And let me just move on. The ticker is not working, the remote control. Go to the next slide. Yes, thank you. So this slide is actually showing a ROADM, and it shows on the 2 WDM lines, the line west, line east. We have the ingress and egress amplifier when an optical or photonic signal passes from line west to line east. We already agreed that we are going to model the ingress and the egress amplifier as part of the TE link. So that's something that's not part of the ROADM. Then the ROADM has some optical channel cross-connect functionality, and of course it also has some optical transponders where signals are added to the line or where signals are dropped from the line to the optical transponder. So the blue box actually is the physical device, and as I have illustrated here in dotted line, and the transparent amplifiers that are there are actually modeled as part of the TE link. And the red path is the express path or the through path, and the signal coming from the optical transponder here on the right is an add path where the green signal is added to line east, and the purple signal coming from line west, and that's dropped to the OT on the left-hand side is then at the drop path. So we've actually identified these 3 types of paths, and we are going to associate the optical impairments imposed by the ROADM to these 3 paths. There's still discussion ongoing whether the optical impairments will be associated with a path, or whether we are going to split those optical impairments up and add those to the ports at the end of the path. So a path has 2 ends, and this is an ongoing discussion. We are going to use the upcoming meetings to hopefully conclude the discussion and reach agreement how to model that. Next slide, please. Okay, I think I explained pretty much already that the amplifiers are part of the TE-Link model, and I already talked about the 3 paths we identified, and we also agreed on at least the 3 parameters that are going to be modeled. So this is chromatic dispersion, polarization mode dispersion, and polarization dependent loss. Those parameters are going to be optical impairment parameters also for the ROADM. There are still discussions ongoing how to model crosstalk. Due to the imperfect isolation of the ROADM components. And we are also going to study how to model filtering impact. So when a signal passes from a source node to a destination node, it crosses multiple ROADMs, and each ROADM applies some filters. And as an effect of passing through the ROADMs, the filter envelope narrows, and we are going to discuss how to model those. There's no solution available yet, but this is something that we have to study. There are some papers available, and we're studying those, how that could be modeled. Next slide, please. When we looked at the different ROADM architectures that are out in the field today, and there's also some evolution towards distributed ROADM architectures. So this is an example of an integrated ROADM architecture. So everything is inside the box. The OTs are an integral part of the box. And from the TE topology perspective, the tunnel termination points are actually located on the optical transponders. Then next slide, please. ROADMs today also provide ports, input ports, output ports for remote optical transponders. They can be co-located, or they can even be remote device. So this is shown by this architecture. So the optical transponders on the left are integrated optical transponders, and on the right side you see that external optical transponders. And in that case, there is a single channel colored optical interface to interconnect these external optical transponders with the ROADM device. Next, please. Now, the two architectures shown before are integrated ROADM architectures where only the optical transponder could be remote. Now, there's a tendency on the market to disaggregate the ROADM and to subdivide a ROADM and integrated ROADM into multiple subsystems. This is shown here on this slide. So you see on at the top the degrees of the ROADM, and you see at the bottom the at-drop blocks of the ROADM and the OT. So these can be separate entities which are interconnected using optical fibers. And the assumption here is when you have a disaggregated ROADM that the optical domain controller is actually, when it provides the TE topology to a client, it aggregates already the disaggregated ROADM into an abstracted ROADM, and for that ROADM the optical impairments are actually provided. So we assume that certain abstraction is taking place in the optical domain controller, so that we don't have to actually model all the individual subsystems of a disaggregated ROADM. Next slide, please.
So, Dieter, I would like to have one quick comment. So, regarding this picture, this is more like kind of architecture for ROADM, right? So, where is this kind of picture from? It's from IETF recommendation or from some other place like Open ROADM?
Yeah, the Open ROADM architecture looks exactly the same. Yeah.
But anyway, I think from the data plan perspective, we should follow IETF recommendation rather than following Open ROADM or
But in general, this can be an example of architecture when you don't have a centralized fiber or lambda switching inside, and this is one of the most used in the industry today. And so this is applied whenever we want to, let's say, identify a virtual node composed by different modules. And then the goal is to understand here also whether this model can be in some way described using the Young models or not. No. The debate is still open, as Dieter mentioned, for example, whether to assign the optical impairments to ports or to path or internal path of the node. And so we think by next IETF we'll clarify exactly the way we want to model internally and as a black box the ROADM function.
And the reason why we're actually looking at this kind of architecture is we have to make sure that the model that we are defining covers all different architectures. So that was the reason why we did this study, and why we also looked at the disaggregated ROADM architecture. So the model that we're going to define should actually cover all the different architectures of ROADMs which are out there in the field or which are currently evolving.
Exactly.
Yeah, I agree with that. Otherwise, we risk to have something that covers just 10-20% of what's in field.
Exactly.
If we wanted to make something that is useful, we should try to cover at least a good portion of the installed base. So, yeah, I mean, it's a pity if this is not a fully standard architecture mandated by ITU, but I mean, I have the same feeling. This is widely deployed, so it's worth having a look at it, in my opinion.
Okay, thank you.
Hello, it's Deborah. This has really evolved. It looks very good. The document's really evolving. There's a lot of information. I would just warn you to be careful. And this came up already now. Make sure you're referencing standards where you can reference them. because this came up on the Yang alarm module, remember, with that one, I think it was when doing the review for when we were last calling it, folks all said, where did you get this from? And put something in the descriptors to say references to what standards you are doing throughout. So keep track of it now before it gets at the very end, right, that you have to go back and add all this. And even on these models, you can you can say something, reference the ITU one, and then just simply say that this is a deployed model or something like that, but say exactly, what this is, so that people know that it's not ITU. And if that way folks can look at it and say, well, this is not compliant or something, but it's something different if it's just functionally an abstraction that helps you to define the parameters, but it doesn't actually deviate. But make sure you're referencing ITU standards. I didn't see any references to the ITU standards like as you go through it. You do at the end with the informative references, but not so much as you go through it. And then just while we're talking about it, then make sure, I think as this is getting very developed now, you should liaison to ITU. It's time to liaison. And they have the meeting, it's like the 3rd or 4th week of January. So, try to get it kind of clean version and just get it there like the 1st week of January or something like that, so they have time to review. And they had sent us back something on the OTSI, so I assume you guys now updated and aligned with that, right? That liaison. Okay.
I mean, we discussed at the previous meeting also that this document is also related to the new IETF recommendation G827, and we submitted AAP last call comments, which are currently under resolution. We discussed that briefly also yesterday during that meeting that we had among the contributors and co-authors of the draft. We'll have to see how that AAP last call comments will be resolved, or whether we need to have some further liaisons or interaction with the IETF.
I think it's important now, before you liaison, add those references to where you can for the standards, and clearly say why you chose, you enhanced models to, like, for example, for this, and why you did it, so that they can read it and understand. Otherwise, they're just going to send it back to us and say exactly as Fatai said, oh, this is, not compliant.
And a little bit we need to be a little bit careful when we turn to the IETF, because 807 is different with the data plane. 807 is a general architecture, and this is architecture in compliance with IETF data plane technique. So we may need to have two groups of input.
Okay, next.
Yeah, actually, I would like to amend it. So I think regarding the, ROADM architecture, this draft should not only reference to G.807, but also, G.672.
Yeah.
G.672, this recommendation really talks about architecture for the ROADM, but actually this draft didn't reference to this recommendation. So please double check.
Yeah, I think I agree. I think we have to agree. We have to add some more references to the IETF recommendations. Right. That's a good point. Yeah, we'll take that. Next slide, please. Okay, we also looked at 3R regenerators, and we actually discussed through realizations of 3R regenerators. One is shown on this slide. This is what is called the back-to-back configuration of two OTs. So that means that the client ports of the OTs are used to interconnect two OTs that form the 3R regenerator. Next slide, please. And there's another implementation possible where you actually use...
Sorry, Dieter, a question.
Yeah.
The 3R regenerator is considered just within the context of a ROADM.
Yes.
Because they could. I mean, as far as I remember, we can have regenerators also without a ROADM, right? Like in the FODAM, don't we?
Yes, that's true. But again, as I said initially, I think we just started looking at 3R regenerators, and these are just two possibilities where the optical transponders in a ROADM are actually used as a 3R regenerator. There are other architectures or
yeah, but my question is whether the regenerator is tightly coupled with the presence of a ROADM in the network. I don't think so. Right.
Okay, this is probably something that we have to discuss, but our assumption so far was
just an input.
Yeah, no.
Gabriele speaking. In general, if you have a regenerator based on lambda, you need a RODM because you have to
usually
open all the spectrum
OT,
and then select the lambda you want to regenerate. In general, so that's why we combine the regenerator to the RODM architecture. But in any case, is a plus, no? So I don't see.
No. I mean, I would like not to leave out the possibility to cover a lot of legacy stuff where regenerators are used in a no-RODM nodes. There should be still some of them in field, right?
In this case, you don't have a DWDM line, so you just have a regenerator, a 3R regenerator that is working on a single channel. That's it. One fiber, one channel, one regenerator.
Yes, exactly.
Okay, we can cover also this stuff.
I don't know. I don't have the feeling of what's the percentage of those type of nodes in the network.
Very.
If it's
very,
if it's very low, probably it's not worth trying to cover it. If there are some, it's probably trying to model them.
I think this kind of regenerator were very used in Sonnet SDH networks.
Yes.
Now with DWDM, usually you have multiple lambdas in a single file.
But if you have the feeling it's not worth it, you can leave it out.
Okay, thank you.
Thank you. Next slide, please. Okay, what are the major changes on the draft with respect to the previous version? So we actually added some text and figures describing these RODM architectures, which I just presented, and the Yang model in the draft is still unchanged because what we need to do first is we need to agreement about the optical impairment parameters, which we're still discussing, and once that is there is agreement about the optical impairment parameters, we will then look at the Yang model and we will try to figure out where the augmentation should occur and should be done. Next slide, please. We're using GitHub. Currently, we are using an individual account on GitHub, and we had some discussions between the previous meeting and this meeting whether we should create a CCAMP working group organization GitHub account. This is the proposal. There is some internet draft available that describes that, how to set up such an account. I think it makes sense to put all the related Yang models on that GitHub. So that's the TE topology Yang model with the optical impairments. Then there's that's using layer 0 types. There's layer 1 types, which is a working group, which has a working group status. So the proposal or the suggestion here is that we should actually create such an CCAMP working group account on GitHub where we put all the material together. And that helps us also to keep the material pretty much aligned.
Yeah. So talking about this, we discussed about the possibility to have a CCAMP GitHub. We are happy to do that, to put it in place. Actually, I read the draft talking about organization GitHubs, and it seems that sooner or later we will have in Data Tracker the possibility to create one.
Okay.
I've not yet seen it, so I don't know what's the timing for the implementation of such a tool from Data Tracker. If you believe that we should have it soon, probably what we can do is to create it, and then I've seen that there is also procedure to move an existing organization GitHub to let me say IETF control. So we can create it as independently and move it later. That's something that we can.
And that's exactly what we're suggesting. So we can take that offline and hopefully create it. Yeah. Next slide, please. We have a number of open issues which are also listed on GitHub. This is just a screenshot from our open issues list on GitHub. Next slide, please. Next steps. So what are the next steps? We want to conclude now the discussions that are still ongoing regarding the modeling of crosstalk in ROADMs that lead to a degradation of the optical signal due to, and that's going to be modeled as an OSNR degradation. As I said, we need to identify the TE node entities, the containers in the TE topology Yang model that are suitable for the optical impairment augmentation. So there we have to take care about scalability, because we looked at the connectivity matrix initially, but the current status of the discussion is that probably that's not suitable, and we will probably have to find another place or a definition of how to model the optical impairments. We had some discussion yesterday during the meeting on this specific topic. And then we also have to study what the filtering impacts are on signal quality and how to model those. We will also have to address then the 3-hour regenerators, which we just briefly discussed in one of our calls. And of course, we have to address the other open issues listed on GitHub. Next slide, please. And that was it. Further comments, questions?
So I think you already spent 25 minutes, so okay. We can have more discussion on the list. Yeah, next one.
Sorry.
Good morning. I'm Sergio Bellotti speaking. Good morning, everybody. Ciao, Daniele. I'm going to make an update about the layer 1 types and the OTN topology Yang model. So this is the main content of IETF layer 1 types. The basic point is that the intention is that to use the definition of different structure, audio type, and client signal for all the related document, that is OTN topology, OTN tunnel, and IETF layer 1 GSM module. So the basic changes of in the layer 1 types is that okay, we check the RFC 8407 Yang guideline, and basically the important point is that we added a section in which we described the usage of the different grouping. In particular, we also better define the relationship between TPN and the tributary port number and time slot. And so defining what is the OTN label that is defined in the drafts that usually represent how the tributary port is assigned, how the relationship between the tributary port number and what is the tributary slot on the server that is assigned to carry that. This is well described in RFC 7131, and we reference that in the document. And basically, we rename a few of the groupings name to fit better with the OTN term. So basically, we define the OTN label restriction and with the OTN label range info and OTN link label and OTN path label, both with the OTN label start and OTN label hope. And we try to define how to use that. Unfortunately, at the moment in the test, there is some misalignment with the name, so we need to adjust that, but the basic explanation is there. Okay. Then we added the leaf list for ODU list type to define which ODU type can be supported or not in the label range. If it is empty, the range means that every ODU type is supported. We also remove in the signal the ODU CN because it's not a switching type. And okay, we changed the range of TPN and tributary slot from 1 to 4095. And we add back the coding function that is defined in MEF 63 for the usage that is used in layer 1 GSM. So the next step of the draft is is done. The alignment with the IETF TA types and topology and the tunnel and the layer 1 GSM, but is still open the alignment with layer 0 type. In particular, the grouping names that is defining IETF layer 0 is still reporting the term restriction. We would like to align both the types with the correct name. Our intention is to request the working group last call and young doctor review. Okay, so this is instead the update for OTN topology. There is we just put as a reference the content, basic content of the young tree, but there is no real modification of that. So there is no changing test, but the model has been changed, reformatting the tree to satisfy the problem of line length restriction, and has been harmonized with the layer 1 types. And in particular, have been added the OTN label step and set default at 1 for OTN. For next step about the topology, we request for working group last call and doctor review together with layer 1 types, and Daniel already mentioned that. And okay, this is the reference for the two model to check. That's all for.
Any comments?
Rob Wilton, Cisco. Is it the layer 1 types and layer 0 types you asked to review together, or those two models for the Young Doctor review?
Sorry?
Which models are you asking to be reviewed together for Young Doctor review? You may know the answer.
For layer 1, the chairs already sent it to the Young Doctor review. Layer 1 types. Yeah.
Layer 1 types.
So which one are you saying together with layer 1 types? What's that refer to? Does that refer to the OTN topology module or layer 0 types?
No.
Yeah, let me explain this. The layer 1 types is fundamental identities in OTN technology, and the next one, OTN topology, is highly dependent on the layer 1 types.
Okay.
So that's why we suggest to review together.
There was
But the truth
slide,
now,
no?
the
In
progress
which
now.
there is the relationship. So layer 1 types is common, is used by the three
Yeah,
models.
the progress so far is the chairs has sent the two documents, layer 1 types and the other layer 0 types together for your Young Doctor review because of their correspondence at different switching layer.
Okay.
So there would be also a layer 0 topology, like W-SON topology, sending to you as well, I believe.
So I think I understand. Okay. Thank you.
Okay, next. So thanks for you that you help us to have a few minutes back.
Okay, good morning. Okay, this is Hamian speaking, and I'm going to present two documents. Actually, this is the layer 0 correspondence to the previous presentation. One is on layer 0 types, and the other is on WSON-Young, which is the WSON topology. Oh, it works great. So we have the similar content as the previous presentation. So firstly, we focus on what is the model relationship. And the first document we are presenting includes the module IETF layer 0 types, which is fundamental identities to be incorporated in both topology and tunnels. So here. And from this table, we also indicate what kind of types we have been included for layer 0, because there are multiple modules would rely on the layer 0 types. So currently we have included the basic identities would be useful for DWDM, CWDM, and FlexGrid. So what we have not included so far would be somehow like the impairment present, and also the interface, another draft. So, okay, so here we give a detailed list of what kind of types we include node, wavelength allocation, termination, bandwidth, channel spacing, and FEC. So the details are listed here, and also in the module, of course. So the changes from last version, okay, this is actually the Young Doctor has already provided one iteration of review. And we have some editorial change like the terminology change, and we also change our central frequency as a type def into the new type with together the description. And the one issue marked as red here has not been changed so far. This is how many digits after fraction we should keep for both gigahertz and terahertz. So basically, a proposal would be we keep 1 digit for giga and 4 digits for thertz, and the example would be here, like we consider the central as 193.1 terahertz, and this would be easier to understand and read. So the one here has some kind of ambiguity and would like to be changed. And we would like to raise this point to the working group to make agreement, and then we feedback to Young Doctors, and we are lucky the Young Doctor is here today. So yeah, the next step including a few steps. The first group of issue. Okay, let me finish it very quick.
Okay.
Yeah, so the grouping name change from the OTN models also impact the corresponding groupings here. So we are proposing 3 different grouping name changes as follow. And that's all the open issue we have notified. And we believe after today's discussion, we can provide one more update and then proceed those versions to Young Doctor review. Okay, I'm done.
Okay, sorry. Greg Mursky, ZT, if you can roll previous slide, because, okay. So, where you plan to have fractions, because here you have in16, and with in16 you cannot have fractions. You need to have the other. In16 would not allow you to have fractions.
Right. Here is the type def is under in16, which is DWDM -N, and we are using the kind of I cannot remember the detailed name, but which stands for the nominal frequency. And nominal frequency is the numerical value of the frequency on the spectrum, and this is can be the central band would be 93.1 terahertz, with the channel spacing usually 12.5.
Right, but you basically you can have a union of two decimals, and then for gigahertz you have a digit 1, and for terahertz you can have digit 4, and then union of these two types.
But if I correctly remember, M and N are integers, aren't they?
Right. M is a slot width and usually measured by gigahertz, and the other is nominal central frequency, which is usually by terahertz.
Okay. Okay, I'll double check, but I don't think that, because integer is that an integer, it's not a float.
Just to clarify here, number one, the anchor frequency is 193.1 period.
Yep.
And second, either you use n and m values, at this point are integers, or you decide to use frequency, and in this case you should have 5 digits after the comma. So the fraction digit 5.
You prefer 5 digits for tera?
5
Okay.
digit.
Because you want to consider the 6.25?
No, you have to. Here we are talking about frequency. The frequency is 6.25 gigahertz.
Okay,
So
6.25. Okay. I
2
see.
digit plus 3 is 5.
Then can we say, okay, 2 for giga and 5 for tera?
No, 5 for tera and 2 for giga. So 6.
What's the difference? Come on.
No, it depends. No, if you talk about gigahertz, is 6.25 gigahertz.
Yeah.
So you have 2 digits.
2, yeah. 2
If
for
you
giga.
translate in tera is 5 digits.
Right. Okay. 2 and 5.
Peter was here just to reply to Greg. We have these are two types. One type is when you want to represent the central frequency slot width of the filter is an integer. If you want to represent something like the signal, OTSI central frequency, then it's a terahertz or gigahertz. So are two different types.
So I also have one comment. So it seems there are 2 types of units. So can we just use one unit? For example, we just use only gigahertz rather than use gigahertz. Sometimes we use gigahertz, sometimes we use terahertz, terahertz.
Yeah, it depends. Sometimes it's more readable to have terahertz. Sometimes it's more readable to have gigahertz. So I don't know. We can look at some examples.
If we only want to have one, we would slightly prefer to gigahertz.
Yes.
Yeah.
But you risk to have a very big number in front of the
Right.
of the comma. That's sometimes difficult to read when you look at JSON. But yeah.
Yeah.
Dieter Bello speaking. I mean, this actually concerns me a little bit, because we also had some discussions when we discussed the carrier frequencies for the TE topology model for the optical impairments, and there we agreed that we are going to use a certain number of digits. I don't remember whether it was 6 or something like that, but you can look it up. And so the question is really, how do we get alignment for the layer 0 types across different Yang models that are using this type definitions?
So the gentleman stand behind you should be a good answer.
So Rob Wilson, Cisco, as a Yang doctor, just going back to your point you made about sometimes it's more readable to choose different units effectively. I think generally in Yang it'd be better to choose one and then do that conversion on your client side. I appreciate the raw JSON coming through on the protocols, you'd have a longer number, but any GUI or something similar can obviously correct it to easier units. Yes, but then it's less work when you want to compare those values between different places. So mostly if you use different units, different places, you're putting extra work in to then convert them, more likely to have errors in that case. So I'd probably suggest, unless it doesn't make sense, to try and keep them in one. In terms of trying to get commonality, I think it's just reviewing those modules together, the types modules, and making sure that they're consistent, which I'll try and do so. I'll review them at the same time. But you're writing the same, same teams are writing the modules, I presume. So I don't know exactly how it's being used, so it's hard to judge. So if your models naturally have different ones, then it might make sense. But if it's a value that you might be using in multiple places, I would try and keep it in the same units, and I'd probably go. I don't know whether gigahertz or terahertz makes more sense. The only other comment I'd make is it seems like the size of these channels is getting smaller and smaller over time, so you might want to factor that in if that's the case, and hence the number of digits you might need will increase over time, so I don't want to factor that in.
Greg Mursky, as I promised, I'm back. So yes, if you want to have digits, decimal digits, you use decimal type, and then you say fraction digits. If I understood the comment is saying, don't differentiate the gigahertz and terahertz, just convert to one and express it with a number. It's so much simpler.
Okay, yeah. So we have agreed on using only gigahertz, I believe, right?
Yes, and then you can specify, you can have, for example, decimal 64, decimal 32, and then 5 fraction digits.
For giga, we don't need as much as 5 digits.
Okay, then 2.
Maybe
take
2 or 3.
Because if you put here 1, you probably need 2.
Okay. Good.
Yes, but please make sure to be feature-proof, because after 6.25 there is a 3.120 and
that's why I mentioned
20 something. 3 digits is the next.
Okay.
Yeah, Dieter, again, there's one more comment from my side. We discussed yesterday briefly in the site meeting. If this is going to move to working group last call, that's going to be frozen. So and other work is still work in progress, and we may actually have to define additional types. For example, for the T topologies, the question is, do we have then to create a new revision of T layer 0 types, for example? So this is something that we should better understand how the process works.
Yes, great. Yeah, great. So I'll move to the next.
Hi, sorry for my voice. It's Italo from Huawei. Discussing some couple of models related to the transport client signal. So one is about the working group document on the client signal model.
That's not work.
Okay, so the status of the work after it was not presented in the last meeting, it was presented in 104. So the document has been adopted as a working group document in May. We didn't do major changes. We don't do any change to the text after the adoption, but we did some changes to the model. We have added, for example, the new service types, which are intended to provide all the types that can be used for describing the client signals. And in particular, we expect a lot of new types coming up from the new work that will be presented later on performance monitoring at OIM. Next one. And we have added for the transport service, we have added a new container to configure the protection and restoration in case you want to do protection restoration in the client layer rather than in the server layer, especially if you want to do dual homing. And we have added, expanded a little bit, the way you can configure the underlying tunnel that carries the signal, the distinguishing between the case where the underlying tunnel is an Ethernet tunnel or it's an OTN tunnel or it's an MPLS-TP tunnel. The reason is that mainly because MPLS-TP, for example, has to take care of also the pseudo wire and the pseudo wire switching. Next one. And we have updated also the transparent client, basically adding a direction attribute that allows configuring unidirectional and bidirectional services. Next one. So what we have a set of open issues. All of them are tracked into an individual GitHub area, and the next steps are to harmonize particular models with other models like performance monitoring and OIM, and we are thinking to extend additional information. We got some feedbacks about people wants to know whether the access link is an electrical or an optical interface, or what is the performance that you want to monitor on this type of signal. So we think the document is still open and requires more work before going to working group last call. So we get a lot of comments, we have already a lot of open issue. We are receiving feedbacks from the operators who are starting to use it. Next one. The next topic is an individual draft, is about the Ethernet T topology. We presented this draft in the last meeting, and this draft is basically taking care of two items. One item is to discover the access links in case of Ethernet services, and the second item is to provide a TA topology in case you want to set up Ethernet LSP. Next one. So we didn't make any major changes after that 105. We just aligned with the model guidelines in RFC 8407, and we have harmonized with the other YAM modules, but no other changes. The only point, this document has been used by the transport and VI design team mainly to discover the access links. We just recently discovered some bug which has been fixed yesterday or the day before yesterday. And next one. Basically, we think this document is ready for being adopted as a working group document. Thank you. Any comment or feedback, especially on the...
Any comments? No comments? So if there are no comments, I would like to test the temperature. So for the next step, you are asking for the document, right? So I think actually this draft has been presented for many times. So the first question is that how many people have read this draft? Very many people. Okay, so how many people think that this draft is ready for WG adoption? A pretty good number. So how many people don't support WG adoption? Okay, none. So let's take to the list. Okay, thank you.
Thank you.
Okay, good morning. This is Gabriele Francisco. Okay. Okay. So here we have to present one regarding the LMP that extend the LMP to the DWDM interfaces. And then this is used to determine and exchange information between the DWDM transponder and the network roadmap. So this is extending the RFC 4209, and then is supporting most or the optical impairment and the characteristic of DWDM interface defined by ITUT. In the past has been done a liaison with ITUT, and then we got some recommendations. So we extend what is the application identifier, adding the output power, current input power, and the input power range. This document is a working group document since March. We didn't do any presentation at IETF 105, and there is this presentation today. The modification to the document actually are some cosmetics, but the most part of the modification is related to the use cases that I really have to encourage to read. This draft covers just DWDM and legacy interfaces, so 2.5, 10, 40, and 100 gig. Does not support all the information related to the flex spectrum, for example, where those information are reported in a individual contributor draft that is CCAMP Flex interface LMP. Now, also considering the discussion is going or is in progress in ITUT about those new parameters, we might decide that either to let's say close this draft and then go in the last call, or keep this draft open, include the information related to the SSON, and drop the individual contribution draft. That is, I think, is a decision that I would like to ask to the working group.
Excuse me.
Yeah, please.
I'm glad to see the slides here saying LMP is not for configuration. We agree on that. But what you added as a use case, two new sections, 3.3 for configuration and 3.4 for some kind of operation or maintenance. So why we need to describe this use case in an LMP document?
Let's say for the maintenance is actually helpful to share information between the RODM network and, in case, the client network, when the client network is supporting the DWDM interfaces, because those two may have different controllers. So share information may help the controllers to understand what's going on.
So that only help on the maintenance between neighbors. It's not end-to-end.
Yeah.
Okay, how about configuration? Again, 3.3.
The configuration is not to configure. Is LMP doesn't configure anything, just share information between the two. And this is, let's say, a statement for the LMP definition. Okay, then the other draft. The other draft we have to present today is again related to the interface, DWDM interface parameters. This draft is supporting the definition of the DWDM interface parameter, extending or following the other two draft, which is WSON impairment validation info and WSON impairment validation encode plus RFC 6566. This model, the YAM models, extend the IETF interface model, and then is a parallel document to the optical impairment topology YAM, where in this case, in this draft, we describe explicitly the interface parameters. Another question here is whether to let's say match the two documents. They are working in parallel, no, and they are complementary. We decided to keep them as a parallel project in the meeting we got in I think in Prague. But again, the team is needed to keep let's say any decision from the topology models team into this. Again, no let's say no modification has been done since last version, just in cosmetics and let's say editorial improvement. Today, as I said, we are working for the last call in sense that we are not asking the last call today, but we'll follow the impairment topology YANG progress. So when there will be the time, we'll ask the last call. That's it. Again, last but not least, we need to keep in line any modification done in ITUT, because this is quite a hot topic. Thanks. That's all.
So any comments?
Just one comment, Dieter speaking. This Yang model also use layer 0 types, or doesn't it use it yet?
That's a good question, Dieter. So we need to understand whether the L0 type will be referenced to from this document, or we augment the IETF interface models. We need to understand together how to deal with this, because either we reference the L0 type, but in this case we have to add some types related to the interface over there, and I don't know, we augment the IETF interface types plus the DWDM. Okay. We need to understand. I think we should discuss offline on this, Dieter.
Yeah, I believe that you should also use layer 0 types for the interface Yang model.
Yeah,
preferably.
But does a L0 type extend the IETF interface models?
Either speaking, I don't think you need to.
No.
You can extend the IETF interface model in your draft, but you can use layer 0 type to reuse the same attributes and groupings between optical impairments, and so you can have a grouping in the layer 0 types, and then you can in the optical impairment we can say we can use this grouping to augment the topology, and in your draft you can use the same grouping to augment the interface.
Okay, as soon as we avoid any duplication, it's okay.
Yeah, that's the idea.
Thank you.
Because there you can get a much better alignment among different Yang models. I mean, this is all the purpose of the having the type definitions and groupings defined in a separate Yang.
No, that's okay. That's okay, Dieter. Thank you.
So, Gabriele, I have one question. Fatih is speaking. So, regarding the LMP draft, I saw the new section on the use case were taken from the framework document, right?
Yes.
So I assume that the use case in the framework document will be deleted, right, later on.
To be honest, I don't know what would be the fate of the framework. So
we got some
for the moment
comments or suggestions
no,
on the framework document.
Yes, and, I think the framework now is stuck, waiting for the last call.
Okay.
And the author, we discussed a little bit among the authors, and we don't know what to do and what would be the next step.
Okay, maybe one approach is that just leave the framework as it is, and then we can move forward. We can just focus on the solution draft. And
the very worst case could be that the framework will be dropped.
Okay, good. Thank you. Yeah. Okay, next.
Morning. Yeah, this is Fan Yang from Huawei. Before we jump to the problem statement of the Flexi interface management, I would like to recall you back to the work that have been done from last 2 years since IETF 1998. Please next slide.
You can also press the
this
button.
One?
Yeah. That's not good.
Okay, and what is Flexi? And Flexi provide a variety of MAC rates that could be more flexible than the existing Ethernet PHY rate. And why we have this Flexi introduced besides the traditional Ethernet? 3 reasons. First, from the perspective of the operators, new services requires the flexible bandwidth granularity, not limited to the fixed file rate like 10G or 40G or 100G, etc. And second, there is a mismatch of the rate development between the Ethernet and also the transport network. They should be decoupled and maybe find a better way for the Ethernet for the transport network to fully utilize the huge bandwidth of the Ethernet port. Last but not least, on one hand they are decoupled, so on the other hand, there must be a simple and efficient mapping mechanism provided. Okay, here are two figures, and I assume that everyone is familiar with the first one above. And the second figure is the management architecture of the Flexi interface. We have two nodes here, and the nodes could be the routers or the OTN equipment. And inside of the node, there is an element management function and also the data plane. And there are netconf or restconf sessions between the SDN controller and the EMF. For the data plane, that we assume it should be the Flexi shim. Here, the Young model we talk about, I want to clarify that it is the southbound Young model from the view of the controller. Here, I'm not going to give you every detail of the Flexi because that is not the scope of this presentation. And I just want to give you the names that there is a Flexi file and Flexi group and also the Flexi client. And also the more information defined in the Flexi overhead frame, that is the calendar configuration A and B, and also the calendar configuration and the request and acknowledgement of the calendar switch. Okay, and regarding the problem statement, the draft is aiming to provide to illustrate the fact that should be considered when you work on the Young modeling, and also the last line of each problem statement. And for information, the last line of each problem statement in the blue font are the reference options that you may check in advance, because my colleague later will give you more information in the following presentation. So the first problem statement is to provide a service function of the various macros. That's the basic function of the Flex-E. And the second one is to meet the requirements of the transport network mapping scenarios. The OIF Flexi implementation agreement defines the three scenarios, including the Flexi unaware and Flexi termination and Flexi aware scenarios. The difference of these scenarios are the how to utilize the calendar slots. So similarly that how to manage it in the Young model should be the one the key question for us. Third one is how to configure the Flex-E. The OIF mentions there is a static and master slave and SDN ways to configure the Flex-E, but there's no accurate definitions of them. And also, it is said it is not limited to these three configuration ways. So that it is so how to provide a generic Young model could be how to provide the generic Young model easier to be extended to provide more to provide further configuration way. That is the important or the key question that for us here. And the fourth problem statement is to as we introduced previously, that There is calendar configuration A and B, and also the signaling information, including the CCCRCA. We think that we should ask that if should they belong to the work of the data plane, or are they necessarily that should be exploited to the controller? So that's the question. Next one is after we finishing the management of one Flexi client, it is the intuitive way to think about the second step to manage the multiple Flexi client from the perspective of the view of the operators. And the last one is to support the bidirectional traffic or not. So far, all the Flexi links are all bidirectional and symmetric links that with the same configuration on both ends. It seems that the unidirectional parameters TX, RX is not so necessary and somehow is duplicated there. So I think that's another important aspect that we should consider, and that's it. And that's all. So thank you. And I want and all the reviews and comments are welcome. But I'd appreciate if you can hold these comments a little bit after the following presentation, because you may have a lot of questions to discuss the details of the Flexi, but actually the following presentation that's give you more details, you may find the answers to there. So yeah. Okay.
So Chile, are you okay to have more discussion after the three presentations?
Yeah, if not, but if you relate to the
now?
problems there, and we may discuss, but if that's related to the details of the Flexi.
Just one question.
Yeah, sure.
Could you please go back to the previous slide? Okay.
Yeah, which one's previous?
Okay.
This?
It's about the negotiation protocol.
Yeah.
From my understanding, I think we should be careful not to invent any new technology for Flexi. It's because I think for this protocol, I can't find any definition in Flexi data plan standard. So from my understanding, if we define data plan protocol here, it does not make any sense. I'm sorry. Okay.
Yeah, I think the data plane. Yeah, we have the same thought that the data plane, the elements from the data plane should not be included here. So I'm sorry, I don't see the difference. Yeah. Thank you.
I will answer your question. Actually, Yuan Jiang from Huawei. Actually, we don't introduce any new protocol here. It's just reusing the data plane protocol defined by the OIF.
Yeah, I think you may, maybe you misunderstood I say it negotiation protocol. There's actually no protocol there. Yeah, you can find the details in the draft and also maybe in the later presentation.
Just depend on the description. It's
okay.
Draft.
So not so clear. Yeah, I apologize there. Okay.
Rob Wilton, I had a comment on the next slide actually on these PS5.
Oh, fine.
So you've got a comment there about using our RPCs to control adding or removing clients, but I would naturally expect that to be just regular configuration, declarative configuration. So I would think using RPC here is probably not right, because if you want to if you reboot the router or the device, you'd expect it to come back with the same configuration as before, whereas an RPC would be naturally more ephemeral and you'd lose that state.
Yeah, okay. Actually, RPC, this part is not included in the draft. I think that, I understand the question.
No, please, speak by sequence, not just jump in.
Oh, just answer the question. Since he raised the problem, so I need to answer it, right? It's not a...
No. Let's the presenter to answer, to clarify his question, and
Yeah, actually, it's not quite mature to bring the RPC here because it's not included in the draft. Yeah, I think that's the next step that we will consider to this part. Maybe we can discuss offline that more about this part because actually we haven't looked details of this part. Yeah, thank you.
Yeah, I have a quick question. I just noted that the OIF implementation agreement for Flex E 2.0 is listed as an informative reference. Shouldn't that be a normative reference?
Yeah. Yeah. I'm not. Sorry. I'm not quite sure about the. Yes.
Okay, anyway, I think we are running time, so I would like to cut questions and we can have more discussion after, the three presentations. Okay,
Yeah,
next.
I'll talk to you later. Yeah.
Yuan Long, next for you.
Well, good morning, everyone. This is Yuan Long Jiang from Huawei. The authors are from Huawei, China Mobile, and Fiber Home. This is an update version. The objective of the document is how to configure the Flex group as a network interface, how to configure the files and the clients in this one group, Flex group, and how to map these slots. Secondly, we need to support the FlexE status retrieval, includes all the group files and clients. The third is support of the interface management in both SDN and NMS way. Lastly, but it's not least important, is support backwards compatible with all versions of FlexE. This from a user point of view, the FlexE data plane can be depicted as shown. We have some FlexE clients and on node 1 and node 2, the same set of FlexE clients should be used. And between the two nodes, the FlexE group, which consists of multiple FlexE files. And the FlexE shen can map the FlexE slots requests from the clients into the actual files in this FlexE group. So it's quite a simple diagram. And we can also see, same from this figure, FlexE slot is a basic constructed unit for both client and the file. This is the abstraction of the FlexE management, just adapted from the last figure. On the right is we have a parent FlexE group as an interface, and we have multiple FlexE client as a sub interface, and also some FlexE files under layer. So both FlexE group and FlexE clients can be modeled as a network interface, and FlexE clients can be added, deleted, or configured with some FlexE slots. So it's a very flexible architecture. As we can reuse the IETF interface defined in the RFC 8343. This diagram shows Yang tree. As you can see, the updates are in the red color. We add the support of FlexE content negotiation protocol. It's just a flag. When it's turned on, then we can use the overhead channel to support the dynamic calendar switching defined in the OIF. This is a recap of the last meeting in the CCAMP working group. people think that CCAMP is the right place to start the work on FlexYang, but we need to check the FlexY work done in other SDOs, such as the ITOT SG15. We also need to look into other IETF-Yang models work. Finally, we need to give more analysis on the pros and cons of the existing two Yang models. First, I'd like to introduce the work in the other SDO. First, in July, OIF published the FlexY 2.1 implementation agreement, which asks the support of 50G PHY. And in September, during the Q14 our SG15 engineering meeting held in Gothenburg, there's an agreement that with regard to G.8023 about the FlexY management information, that some of our FlexY management information need not to be visible in the external management control interface, such as the CCA and the CCB, CCCR and the CA. Finally, the TX and EX, that's expected configuration should be set to the same value. That's the agreement in the ITOT. And the next is similar work in the other industries, such as in the IETF. ANA already defined the lag interface, that's IEEE 823 AD lag in OFC 7224. We also found 3 predecessors of a Yang interface with bonded Ethernet links.
So, you have 25 pages, so please speak quickly.
Yeah,
and
I will
some
submit.
general information.
Sure.
Just, go to the
IETF, IEEE, and OpenConfig, all of them have such a bonded link Yang modules, all modeled as a single interface. I will not just skip to some, yeah. That's why the reason why we augment the FlexY from the interface. Because we have many advantages. We use the same style, the same attributes. So the same unified naming style, addressing. The second is why we should not model the FlexY instance. First, the instance number can be inferred from a file number, and the second instance is just the internal things. The usage is not needed in the management plane. Finally, it doesn't backwards compatible if it's introduced in the model. This is a CCCRCA things. I think all the representatives in the ITOT agreed, so I will not discuss it in more detail. This is about the CCA and the CCB. Actually, OIF introduced the CCA and the CCB mechanism just for the headless client configuration. One of the kind is used for active and another used for backup. If we write into the active, then all the service will be impacted, and the loss of traffic will be caused on all these clients. So that's the reason we cannot expose both CCA and CCB to the external interfaces. This is bidirectional. I think we have an agreement. This is how to model the slot list. We use the file as a container for the slot list. It's more compatible. It's easier to find unused or unavailable slots in a particular file compared with the other two options. That's the summary. We compared with two different modules. The first column is Dr. Jiang, and the second is Dr. Xiaoben. As you can see, there are plenty of differences, and we believe I don't want to cover the details one by one, but people can see there are lots of abstractions in the first draft, but all the details are exposed in the second one. But we can find quite a few disadvantages if these details are shown to the manager or to the operators. So, oh, sorry.
You make some trouble for me.
Sorry. The next page is some other differences. The first draft is 4 tiers in hierarchy, flat and simple. The second one is 7 tiers of a tree, very deep and complex. The first is only model the slots. We don't need the bandwidth to be provided. For the second, both are provided. But how to provide these bandwidth values consistently across every application, that will be a challenge, since if we don't give accurate bandwidth for a slot, that's a problem under there. That is only local parameters are included without any remote files be configured. For the second, both of them are needed, so it's more complex. The first supports data retrieval, whilst there's no such support in second.
So
Finally,
I have one quick comment. So I think this comparison table is really very good. It seems that you did a very good job. But what are in common for these two drafts? Nothing in common or so huge difference between these two drafts, right? What are the conclusions? Yeah.
Yeah, its target is manage the flexi group. That's the same, but the methodology differs a lot.
Okay. Okay, thank you.
Yes, but the goal is reaching a consensus. So just focusing on this thing is much better than the other is not helping to progress the work. I would rather focus on synergies and to move on, and not rather on differences.
Right.
Yeah. That's my comment. And another thing, this is I see enough meat in each row of the table to have a deep discussion on the mailing list. I would suggest not to be silent between one meeting and the other, and then present 25 slides of content in 10 minutes, but rather take the 3 months between one meeting and the other to better discuss on the mailing list each topic. That could help a lot at the next meeting to have to work on commonalities rather than differences.
Thank you, Daniel.
At the moment, I see it very, very difficult to adopt one draft or the other, just saying that this work is better, this work is worse.
Okay.
Thank you. Actually, we do sit together to have a conversation with all the authors, but it seems we have very different opinions on how to progress this work. That's the reason we brought all the different opinions on the table, so that every representative can have a...
But yeah, I'm saying it's the wrong table. The right table is the mailing list. Is not the 10 minutes at the meeting.
Yeah, that's a good suggestion. We will discuss more on the details on the mailing list. Thank you.
Okay.
Okay, great.
And if you wanted to arrange periodical meetings like we are doing for microwave, like we are doing for optical impairments, just ask us and we will be happy to arrange them for you.
Thanks.
Okay, Greg Merskiziti, you mentioned that there are some mechanisms in your model that support dynamic slot switching.
That's defined by the OIF. We just enable this signaling.
What's the scope of this switching? Is it switching end-to-end or switching within a link? Because I don't understand what's the switching within a link.
We just focus on the frequency group from one node to another. It's a link, but it's also a chain-to-chain. It's the same.
No. Okay. Switching, you mean the switching as an update or switching that you do switching from one link to another?
No, it's actually switching from one calendar configuration to another calendar configuration.
But
it's not a link.
But that's not switching. It's reconfiguration.
That's maybe some new concept, but that's
not okay. It's not a new
mechanism.
concept. There is a configuration and there is a switching, and we understand certain things with that. Switching, you do switching like in TDM on the box, right? And that's a switching. You do switching between different links. And ITU told us in their liaison not to do switching. Okay, so if you mean it by configuration, then call it configuration, dynamic configuration. So, but you say that you want to use some channel to communicate switching. To me, it sounds like you do switching between links.
No, actually, switching is a concept in the OIF.
No.
We can conduct switching.
No.
Okay, we can
Try
discuss that
again.
in the offline. No problem. We can, if it's a better concept, we can
So
use it.
you're aware of ITU liaison not to do switching.
Yeah. So
I know what is done in ITUT.
They told everybody, don't do switching between links.
Okay, Greg, I think, thank you very much. I think we got your point. We can have more discussion on the list. Okay, for the next, Chile.
Hi everyone, this is Chile. Okay, I also same topic about the flexi and some analysis. Okay, I'm sorry. Okay. Okay, some updates. Okay, and the comments received. I will try to make this brief to save time. And the updates currently, I think there's some update to a data plan about the 50 gig Ethernet file. So we just add this. This is the only update in current draft. And then for the companion draft, the analysis draft, it was updated accordingly to help understanding the modeling draft. It's just to help understand that. And the next, we also received some comments. That is about whether the flexi instance should be modeled or not. We did think about this, and we give some case in point just for discussing. The first one is, okay, look at the flexi overhead. It's replace the file number with the instance number right now. So this is the first evidence. And the second one, okay, in RTUT document, it's about the comparison for accepted value and expected value. Okay, just look at the right finger. And the comparison is based on the flexi instance level. So we think we should align with them. This is the first case. And the next, we give some analysis that maybe sometimes you don't consider flexi instance, this may bring some trouble. Okay, I'll give, for example, in the static configuration mode, if one of the flexi instance, okay, there may be multiple line in one device. If one of the flexi instance fails to be interleaved correctly, it will be replaced with replacement signal instead of a normal signal. If the equipment is configured to only verify at the file level, sometimes it cannot detect the fault of the instance. It's not about the attention to data plan is just try to verify whether it's correct, or whether the configuration is correct from the source to a sink. And the next, another case in point is about the unavailable slots. It's used especially in flexi-aware transport mode. Here we give one example. For example, 150 gig calendar flow is transmitted over 1/2 bound Ethernet 200 PHY with 6 unavailable 5 gig slots in the first flexi instance and 4 in the second flexi instance on purpose. So I think just based on this use case, for the model, it should be able to just distribute the unavailable slots over different instances. And this is okay. The next one is another comment we received, whether the type of calendar configuration A or B is needed. And the answer from me is we'd better do that. It's because that we can't preclude the possibility of how the device can be implemented. Sometimes you just use some default configuration. Sometimes there may be some flexibility. So just also give one example that the static configuration, and in this case, okay, for the source side you use A, but for the sink side, okay, you just configure okay it as B, then there's some inconsistency exists. So it's better, just based on this, the conclusion, it's better to configure the type of calendar at both ends. So just we can't preclude any possibility of how the device can be implemented. We should avoid a vendor-specific model. We should, for the model, I think we should cover as much as possible case. And the next, okay, that's all.
Actually, Italo speaking. I would like to clarify that the 8023 defines the interface between the atomic function and the EMF.
Yeah,
while the YAM model is the interface on top of the EMF. And also in the 92 question 14, we have clarified that if something is available as an MI, it doesn't need to be exposed in the YAM model.
Okay.
And we are also working in question 14 to try to avoid to expose every bits on the wire as an attribute in the YAM model, but to expose only what needs to be configured, managed, and reported.
Okay. So my answer about this is we should give some analysis about the use case to see if in this case the instance we should be exposed. Yeah, okay.
Yuan Longjiang, I have a problem with this logic. The sentence that you quoted from OIF just say that the A is always active calendar, B is never used. How to populate that B is they didn't specify anything. They are not used at all.
Okay.
So why we need to configure it and transmit this configuration to the other side? That's the problem.
Just during the presentation, I already gave the explanation. We should not preclude any kind of a possibility. Sometimes one vendor is true to implement the device in this way, in the default way. Sometimes, okay, another vendor is true to implement this in another way. We should avoid the model to restrict it to one specific case, one particular. We should not do that.
Okay, so you are implying some proprietary implementation, not the OIF-dependent behavior, right? You are quoting something
so.
in the OIF.
I don't think
but
so.
You talk about some other use cases. Maybe you can bring it out so we can see whether there's a solution or there's any problem there, right? We are talking about the OIF things here.
I have already given that explanation twice. Sorry.
Okay, this is Fan Yang from Huawei. I have a different thought here. Also regard to the calendar configuration A and B. If you are going to define this attribute, and then when you assign the parameters of this attribute to the device, and so the running calendar of the Flex E on the device should be disrupted. because you are renting the new parameters there. So I think that that is cause there is an interrupt of the service of the Flexi service. So have you ever considered there is any other way that you may, because the calendar A and B, calendar configuration A and B defined in the OIF, that is the main target of these two, because there are two calendars. Why there are two calendars? Because one is always only one is active, another one is the backup. It's like a backup. Then you have two calendars that if you are going to resize or add the slots of the any modification of the client, that you can use the different calendar to switch over between them and to have a hitless switch over. But if you are going to use the parameters there, that you always there is a disrupt of the service. That so I think it's not the main the initial goal to define this two, because you always disrupt the service. So I mean. Do you have any consider that if there is any better way or the other way, like to model this? Yeah.
Okay, for this slide, it's talk about the consistency between the source and the sink, and not talk about the the thing you just mentioned. This is different. Okay, for the answer to your question, I think we have already considered, but maybe we could communicate offline about this.
Yeah, that could be something that you think about it, I think.
Because we don't have enough time.
Yeah. Okay, we can talk offline and also in the mailing list. Yeah, of course.
Yeah.
Okay. Thank you.
Last question, yeah. It's a quick question or a wrong question?
Rob Wilton, Cisco. So my understanding is there's two competing Flexi models here. There's discussion as to which to go with. Now, I would suggest, and bear in mind, I'd see there's a Cisco author on one of those drafts.
Yeah, Cisco, yeah.
Yes.
From us. Sorry.
But what I would say is, I think rather than concentrate on these details, and you can put, if there's some things that are going to be optional or could be implemented, you can use Yang's features to allow those things to be optionally configured. There's a separate question as to whether or not these things should be exposed or not in a management model. That's a different question. But if some people want them and some people don't, I think you can use if features. My suggestion from a Yang doctor's perspective is to try and get commonalities, to look at the shape of the models and try and get alignment on the fundamental shapes, because it's really about what things do you represent as interfaces, or what configuration do you take out and not put into interfaces. And my understanding is that actually with Flexi, the issues about when do you create those interfaces and when do they get set up, that maybe if you put them under the interfaces, you get like a catch-22 of that sort of issue. So it may be that in some cases that having it outside will fit better, possibly. But I think that I would try and look at the shape and get agreement with those.
Yeah, okay, thank you.
It's not just a Young doctor suggestion, it's a common sense. Please start building something together, guys, not keep on saying that this thing is mine is better, yours is worse, because otherwise we're not getting anywhere. And start with the major issues, because to me the calendar A, calendar B, yes, it's an issue, but it's not the biggest one. I would say that the switching part, the configuration, that's the starting point, in my opinion.
Okay, David. So Danelli, what you said trigger, David to have more questions.
No more questions, just a suggestion.
Okay.
So Dave St. Erickson.
I can see the queue. Sorry.
Go ahead. I'm sorry, I interrupted the He's awake though, which was more than what could be said about 10 minutes ago. No, what I was going to suggest regarding what should be, shouldn't be exposed, have we reached out to the OIF at all? I'm sure they would have an opinion on this, right? So, like, why not put something down on paper as a proposal and go send it over to them and find out what they think about this?
Yeah, this is the possible approach. Yeah. And also, anyway, I think actually, if the authors, all of you, would like to progress this work, you have to sit together, to work together, to have better understanding on each other's, solutions, and you have to converge anyway, right? If you cannot convince the authors each other, how you can convince the working group, right? Yeah. So anyway, you should work together first. Yeah. Okay. Thank you.
Good. Thank you.
Hello everyone, this is Hamian again, and okay, this presentation has 5 pages.
I think you have only 3 minutes.
Okay. Okay, next. So okay, this is a new data model proposed to do the client signal performance monitoring, and this is based on the model. Down a little bit. Based on the service model, we have been we have been promoted in this working group, and we have specified 2 different kind of service. One is Ethernet, and the other is transparent client signal over the let's see GMPRS tunnels. So a generic draft is drawn here to indicate where the performance monitoring is set and where the performance monitoring need to be interacted with each other. So basically, this is kind of for operation need, and the operator need to understand what has been after what has been configured to the network, what is the performance, and to decide the future actions. So the model would be related with a few other models, because besides the performance monitoring, the OAM, alarm, they are related concept, and we will reference to these documents, these RFCs. And regarding the client service, we are generating dedicated performance monitoring models for both Ethernet service and the transparent client service. We have been also aware of other performance monitoring models in TIS working group, focus on VIN and the tunnel, but not on service, so we do it for service. And the other model is from BAS, which on service, but for VPN service. So we focus on the performance for these 2 kind of services specified. And we currently only have 1 parameters for performance monitoring, that is latency, and we use that as an example to kick off the work. And what has been in our plan includes the bit error rate, packet loss, jitter, and so on and so forth. Everything has a specific definition and has a data plane reference to we would look into in our future follow-up. So we don't have to have the plan to define any new parameters so far. So to move forward, I think we need to do a few actions, including we confirm the usefulness of the work in the working group, and we agree on the scope. Especially, we need to think about whether it's technology specific or generic. We have already received some feedback from the TIS working group, and we will talk with other related documents, the authors of other related documents. So that means we also need to agree on the model relationship. So, and then the next step is to integrate more parameters listed in previous table. That's all for presentation. And I would like to ask people to read this and provide us feedbacks. Thank you.
So I think this is the new draft. We still have more chance to discuss on the list. Okay. So next.
Good morning. So this is Yiling from Huawei speaking. This draft is about the ICP extension in support of proactive protection. Actually, it was presented in TIS working group this Tuesday, and it was agreed to move to the TIS working group. But I still want to share it in the CCAMP working group, because I think the use cases of the typical use cases of this draft is very related to transport network. So so your comments will be very welcome. And I'll go through it very quickly, because I know Danielle is having a difficult time. So okay, the background is that the recent public technology shows that that could be some indications before a failure, physical failure happens. So it's possible to do the failure prediction before the real failure happens. So the proactive protection means that if we can catch up with predictive failure, then we can create a protection path before the real failure happens. So that is the proactive protection. So we make protocol extensions to support these kind of functions. So okay, sorry. So this is, could you move a little bit down? Okay, thank you. And this is the main idea. Say on T1, the node C finds that predict that there is a fiber cut, there will be a fiber cut happens in the near future. Then it will notify to node A, and then the node A in T2 can create a protection path to protect this connection. And in T4, if the real failure happens, then we can start do the for example, 1+1 protection switch to protect the connections. And if finally the failure has not happened, if we find that it's safe enough, then we can tear down the protection path to save the resource. And for the protocol extension, I think it's quite simple. We actually add 2 bits to the protection object to indicate that this is the proactive protection. And these 2 bits are used to indicate the intermediate node to start the proactive protection function. As we know, we have the 4872 and 4873 about the end-to-end protection and the segment protection. So these 2 bits are for each other. So for the segment protection is almost the same. And another extension is about the extension to the notification about the proactive predicted failure notification, which is different from the real failure notification. And we also it's optionally we can also include the time before which the failure will happen. And then if no failure happen when for example in T6 in this figure, then the source node can considering to tear down the protection connections. Okay, so for the next step, we have decided to move it to the T working group, and I think I will also copy to the CCAMP working group and to get your feedback from the group. That's it. Thank you.
Okay, Greg Mersky, CT. So you do this end-to-end protection, not a span protection, not a link protection. So it's not local protection. You do end-to-end protection. Okay, then I don't see that there required any extensions because if you do end-to-end monitoring of performance, you can have some policy that defines dynamics of their service quality degradation, and then you can decide whether you are in a zone when you want to instantiate the protection because your really conditions are worsening to the case of close to be a failure. So because of that, if you are doing end-to-end protection, so you do monitoring end-to-end with any performance measurement method, and you don't need to signal anything. So you decide on the head end, thus you instantiate associated channel when you notice that you are crossing this threshold. So I don't see the need of any necessary extension. All the mechanics are already in RSVPTA.
Okay, so let me clarify.
So at most, it's informational draft.
Yeah, let me clarify. Say a proactive failure is different from, for example, the signal degree or signal failure, because from the data plane you can continue to receive the data as normal, no data impact. So you cannot catch up with this kind of information in the source node or the end node. One of the example is that if we keep monitoring on the SOP, the state of the polarization, if fiber is say have a pressures or sketch, the SOP will change greatly, but the data is you do not have any BR in the in the working path. So if the source node do not aware of this event, you still need a notification from the control plane.
Lou, while this is interesting technical discussion, I think we're highlighting why you don't do sort of draft shopping in different working groups. Since we said this is going to be in T's, if we are going to have a technical conversation, we now have to have exactly the same conversation in T's. Mm-hmm. It'd be better to take this to the T's list and have that conversation there, rather than trying to take up multiple working groups' time talking about the same thing.
Okay.
So that's just my opinion.
Okay, understood. Okay. Yeah. Okay. I think meeting adjourned. Daniel, really, thank you very much.
I bet. Thanks to all of you.
Okay, see you next time. Thank you.
Bye-bye. Thank you.